Today, we're going to be doing a vulnerability management lab using Tenable, which everyone can follow along with because everything is done in the cloud. So it doesn't matter what kind of computer you have, you should be able to follow along. And at the end of the lab, I'll show you how you can put this on your resume as experience to help you with your cybersecurity or IT job hunt. My name is Josh Madakor. I'm a cybersecurity professional and owner and operator of the Login Pacific Cyber Range and Cyber Internship programs. There's basically two different ways you can follow along with this lab. The first way is you can get a free Tenable subscription. I believe it's for 7 days, and then a free Azure trial, which you have $200 worth of Azure credit, which you can use for 30 days. And you can use Azure to kind of set up your architecture, which we're going to talk about pretty soon. And you can pretty much do everything for free as long as you complete it within those 7 days. And the second way to follow along is to just simply join the Cyber Range, which is surprisingly cheap, and everything is set up for you already. Like once you join, you get your credentials issued to you for Azure and Tenable, and you can just log in and follow along right away. There's a whole bunch of other stuff in the Cyber Range as well. Not only is there currently over 300 other users actively using it, there's a bunch of courses on vulnerability management, like a full-blown course on security operations and endpoint detection and response. There's a whole bunch of stuff in there, but if you have access to the Cyber Range, you can just immediately follow along with this lab. And I do want to say, if anybody puts a really nice comment below outlining the steps on how to do this lab for free, like sign up for Azure, sign up for Tenable, like set up your VM, like blah, 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 like listing out all the steps, the most upvoted one after a week, I'll contact that person and give them a prize. The only downside of using the free Tenable trial is you can't do compliance checks with that, which we're going to do in this lab, but it's really not that big of a deal. We're going to do vulnerabilities, vulnerability remediation, and compliance checks, but you're going to be able to understand what's going on, regardless of if you have the free version of Tenable or not. I'll put links for everything in the description, like for the Cyber Range, if you just want to sign up and start doing the lab, and a bunch of other stuff for free, as well as like that free Azure credits page and the place to sign up for the Tenable trial. So a quick overview of what we're going to do in this lab. I do want to say inside the Cyber Range, there's like a full-blown like vulnerability management course that teaches you pretty much everything, but I'm going to try to compress that as much as I can to kind of make it make sense to people who don't know what vulnerability management is, just an FYI. So what exactly is vulnerability management, or more specifically software vulnerability management? So it's basically just helping to reduce organizational risk by mitigating software vulnerabilities discovered in the environment. So kind of what this looks like is it happens like it's like cyclical in nature. So maybe like every month you scan, discover a bunch of vulnerabilities, you go through and fix them, and kind of more creep up because more vulnerabilities are discovered, or you added more assets, or you installed more software, and then you scan again the next month and you kind of fix those vulnerabilities and remediate them down, and that just keeps on happening. That's kind of vulnerability management in a nutshell. So you might be asking yourself, like, what exactly is a vulnerability? And there's a lot of like different ways to think about it, but in my head, there's kind of three basic types of vulnerabilities. The first one's like really easy to understand. It's just an out-of-date third-party software. Like, you know, when Firefox or Chrome or Adobe Reader is always trying to update. Usually that's because the vendor discovered some kind of vulnerability that could allow hackers to take advantage of the software on the machine to get extra access or something like this. So a vulnerability is discovered, and then they try to like update it to patch that vulnerability. So that's like kind of a third-party software. The second type of vulnerability that's really common is like as your operating system being out of date. So for example, you notice like when your iPhone is trying to update, or your Android is trying to update, or Windows is trying to update, or Mac is trying to update. That's usually because like Microsoft or Google or Apple found some kind of vulnerability in their operating system and they want you to patch it. Sometimes the updates are for like added features, well, they often are, but there's usually some kind of vulnerability like fix happening as well in the background. And then kind of the third kind of vulnerability that we'll talk about is OS misconfigurations, or kind of an insecure configuration on the operating system. So a really simple way to think about this is with Windows, if you just don't have a password right, or on your iPhone, you just don't have a password, or your AirDrop is always open, or your Bluetooth is always accepting connections from whoever without a password, or your hotspot on your phone is on with like a really weak password or something like this. It's just like misconfigurations in the operating system. So we're going to kind of experiment with those a bit as well. So third-party software out of date, operating system out of date, and then poor operating system configurations. So that moves on to how vulnerabilities are discovered by the scan engine. So what exactly is a scan engine in a scan, and what is all of that about? So basically, a vulnerability scan engine, it's just simply another computer on the network that's doing scans. And by scan, that just basically means the computer or the scan engine sends traffic to the target machine with the goal of discovering vulnerabilities. And I'm going to kind of summarize this a lot at a high level, but basically the scan engine it can attempt to log into the computer. Most of the time it should be doing this remotely, and then look through the file system and the registry if it's a Windows computer, and like the different settings, and discover the different software on the machine and try to figure out like which of that software, if any, is vulnerable, is like out of date. Are there any poor configurations? Is the operating system out of date? Is there any other problems? And then when it's done scanning, typically like a full scan maybe takes like 40 minutes to an hour, which we'll see. The scan will finish, and then a report will be produced for you, and it'll have basically a list of vulnerabilities and like a list of different stuff that it found that was vulnerable on that computer. And then now that you have your vulnerabilities or a list of vulnerabilities, it's time to remediate them. So what does remediation mean? So remediation basically just means reducing risk in one way or another. And there's kind of 4 ways to deal with risk in cybersecurity. Like if you study for CISSP especially, you'll discover these. But the first way, which is the best way, is risk avoidance. That means like completely removing the risk. And what this looks like is if you scan the virtual machine, for example, and there's an out-of-date Firefox on there, if you just completely like rip Firefox out, you like uninstall it and remove everything, that's called risk avoidance. You're just completely removing it from the system, the whole footprint of the vulnerable thing. The next best thing to do is risk mitigation. So Firefox is out of date, simply updating it or applying a patch to fix that known vulnerability is known as mitigating it. It's not the best way because Firefox is still on the computer and there could still be a vulnerability that we don't know about, like a 0-day, but at least we mitigated the risk a bit by patching the known vulnerability and we reduced the risk a bit. The next best way, which is kind of getting into the not good territory, is risk transference. So what this might look like at work is, say you scan your virtual machine, you see an old version of Firefox on it, you go to the like IT operations team and you're like, okay, you gotta patch this Firefox or get rid of it, and then IT operations says like, oh, we need that old version of Firefox because like whatever reason there's some app that needs it. So you say, as the risk department or the cyber department, you'll be like, okay, I guess maybe you can do that depending on your work's policy, but we're going to need you to accept the risk for that in case something happens. Your department is going to take responsibility for it. And if they say yes, then you kind of quote unquote transfer the risk to them. So you're not on the chopping block when something bad happens, but it's not great because the risk still exists, but you're able to transfer it to another like department. This is also the case with if you have cyber insurance, right? You can transfer some risk to the insurance company. That's like a kind of another way to transfer it. Not good, but it's better than doing nothing. And that kind of leads us to the 4th way to deal with risk, is called risk acceptance. What this looks like is you scan the virtual machine, you see an out-of-date Firefox on there, it's really, really vulnerable, and you're just like, that sucks. And then you just go about your day and don't do anything about it. That's called risk acceptance, and that's like the worst one. So when it comes to vulnerability management, usually you're going to be doing risk avoidance, like completely removing the thing or fixing the insecure configuration. A lot of the time you'll be mitigating it by like patching the third-party software. Sometimes you'll have to do risk transference, like you'll have to make an exception for the risk, like if a department needs like some insecure app, but that happens a lot. They try to like get you to do that, but it's less common. Usually you're going to like avoid the risk or try to mitigate it in one way or another. So what are these compliance audits and benchmarks such as DISA, STIG, and CIS? Basically, the best way you can think about these, in particular, we're going to use STIGs in our lab, but CIS is like something similar. DISA stands for Defense Information Security Agency, and STIG stands for Security Technical Implementation Guideline. And these are basically just things that you can implement in your operating system to make it more secure. It's not like vulnerabilities where a vulnerability is like a hole that needs to be patched. A STIG in this case is something that you can do on top to make it more secure. And same with CIS. CIS has like kind of a benchmark. It's like a list of things that you can do to make your operating system more secure. And we can configure our vulnerability scan to look for like if STIGs are properly implemented or CIS benchmark is properly implemented. So in this lab, we're going to use STIGs. and you're going to see what it looks like, but it's going to scan the virtual machine, and it will have like a list of STIGs that passed and a list of STIGs that failed. And I think there's like a third list of like warnings or something. I can't remember, but STIGs will be something like recommend you disable the guest account, or recommend you have a password of at least like X characters long, or I recommend that you do this or that. It's just things that increase the security posture of the computer. So in this lab, we're going to deal with both vulnerabilities, and we're going to do like a STIG compliance audit, and we're going to kind of remediate one from both, just so you can kind of get a sense. And then finally getting into the architecture, and by architecture, I just mean like the different components that we're going to be using, like virtual machines and whatnot. And this is going to be from the perspective as if you are a CyberRange member. So if you sign up to the CyberRange, you get your Tenable and Azure credentials. This is basically what you're working with. But if you happen to do like the free version where you get your free Tenable console for 7 days, and then you get your Azure account, like your month's worth, you're going to end up creating something that looks like this. But I'm just going to explain this in terms of the CyberRange, because it's just more easy and it's more streamlined for people who happen to sign up for that. So basically, this is what it looks like. This is us here. We're just sitting on our living room, right? And then when we log into Tenable, which we're going to do pretty soon, we just log into this. It's just like a website on the internet, basically. And then there's this cloud scanner. It's like a scan engine, but it lives on the public internet. And we can use this to scan our virtual machine's public IP address. But the CyberRange also has like an internal scan engine as well inside of the same virtual network as the other CyberRange computers. So we're going to log into the CyberRange Azure subscription, and we're going to create our own virtual machine inside of there. And then we're going to be able to scan it directly with the scan engine that's living inside of Azure. This is pretty much how this is exactly how the architecture works and what we're going to be working with. So the first thing we're going to do, I'm going to keep referring to this diagram as we kind of work through the lab, just to kind of give you a good visualization of what's happening. But I'm just going to do this as a perspective of somebody who's in the CyberRange, because it's just going to be easy. So if you just signed up for the CyberRange, for example, this is what it might look like. This is what it will look like. So if you click on Classroom at the top to get access to Tenable and stuff, if you go to like Vulnerability Management course and you scroll down, there'll be like this platform rules and agreement, and then requesting access to Tenable. You just have to do this stuff in here, and you'll automatically like get access to it. But anyway, so assuming we're like ready to do everything, the first thing we're going to do is actually get logged into Azure, and then we're going to create our virtual machine, which we're going to be using to scan and install software on and mitigate vulnerabilities and just kind of use for the rest of the lab. So to do that, once you get like request your access to Tenable and Azure and stuff, you'll get these like 2 emails that will look something like this. And then we're going to log into our Azure subscription. So you just click on this. This crazy thing is your username, and then this is going to be your password. So just open up a new tab, and we're going to create our virtual machine in Azure. So just go to portal.azure.com. and you'll end up on a screen that looks something like this. Then you'll put your username, and then just put your password here, and then attempt to log in. I have to use MFA because I set that up. Cool. And then you get logged in. And again, I'm doing this from a perspective as like an actual community member. So this is what you can expect to see. So again, we're going to create our virtual machine up here. So we're logged into Azure and like the corporate network. So I will say virtual machines, or you can always search virtual machine up here. And these 2 virtual machines that you already see here, these are already part of the CyberRange. So just like honeypots on the internet, essentially getting attacked. So we're going to create our own virtual machine. And so we'll put it in our own resource group, which is this crazy long named thing. Every member has their own resource group, which you put stuff in. You can kind of think about it like a cloud folder to hold cloud resources like virtual machines, virtual networks, etc. So we can name the virtual machine whatever we want. So I'll name it Josh VM Lab 00 or something. Make sure it's in East US 2. For the image, go ahead and pick Windows 10. And then for the size, make sure you pick standard DS1 version 2. This is controlled by the CyberRange to keep the cost down. If you're using your own subscription, like pick whatever you want, but it's going to cost this much per month if you leave it on. With a CyberRange, we cover this. So I guess you don't have to worry, or it's part of the fee that you're paying. And for the username and password, don't forget what this is. So for my username and password, I'm going to write it down. It's just a lab, so it's okay. I'll put a lab user for the username, and for the password, I'll just use cyberlab123 like this. So username, lab user, and then cyberlab123. Just don't forget what it is. You can reset it always, but it's better to just not forget it. And then make sure you click confirm I have rights, and then say next for disks. And then if you're on the CyberRange, you have to set this to standard HDD. It's another cost saving thing. And say next for networking. And if you're on the CyberRange, you have to put CyberRange VNet, because everyone joins the same virtual network. All the different students, there's about 300 people, at least at the time of me creating this. And go ahead and click delete this when the VM is deleted, and say next for management, and then next for monitoring. And we don't need this, so disable this, and say review and create. And validation is good, so we can just say create at this point, and the VM will take a few minutes to create. So while this is creating, I'll just kind of do a recap. We just configured and created our virtual machine inside of the Azure corporate network, and it's just being created right now. So after this virtual machine gets created, we're going to actually log into the Tenable account, and then we're going to create a scan configuration that we're going to use to then scan the virtual machine that we just created. So we're just going to kind of wait for this to finish, and it finished actually. So our virtual machine is finished. So let's go back to VMs, and let's try to just log into it. So we're going to log into the virtual machine we just created and kind of do a few things to prepare it for scanning. So we'll click on our virtual machine here. This is the one we just made. And if you're using the CyberRange, you can connect to it with the Bastion host. This basically lets you directly connect to it within the browser. It costs extra money, but it's convenient in the sense that you don't need to use third-party software like a remote desktop or something. So the username, we'll just put what our username was, so lab user, and then password cyberlab123, and we'll get logged in and connect. Should open a new window. There might be a pop-up blocker for you that says, are you sure? So just allow it to do a pop-up, and then we'll get logged in. And you notice I'm on Mac, but inside the browser is running Windows. This is the virtual machine we just created. And this is taking some time to log in. We'll speed this up. So when we got logged in for the first time, we can turn all this stuff off, like so. It'll take a bit still. So when we get logged in, we're going to actually disable the Windows firewall. In the real world, you would just make an exception to allow only the scan engine into your network, but it's kind of error prone doing those surgical type things in the lab. So I'm just gonna, if you're following along, I'll just have you turn them off, turn the firewall off. So just click Start menu. Make sure you're not clicking your own computer. Make sure it's inside the browser, right? So you might want to make it slightly smaller so you don't get confused yourself. So click Start and type wf.msc. And click on this. And click on Windows Defender Firewall Properties. And then turn all these off. So you can just press O and it will turn off. Next tab, private profile off, public profile off, and OK. And then there's one more thing we have to do. So click Start and then type PowerShell, and then open PowerShell as admin, or you can right click it and say run as admin. And then you don't have to do this for every version of Windows, but it's hard to tell it's hard to explain, but it's hard to tell which image Microsoft is deploying that day when you created your virtual machine. But basically I'll put this this checklist in the description, but you have to run this command on the computer. This basically in PowerShell, in the admin PowerShell. So copy this. If you run this command, it basically makes it so you can execute commands remotely as an admin. So for example, if we ask ChatGPT, what does this do? It should give us like a decent explanation. And here's a summary. This specific registry setting controls how access tokens are filtered for local accounts when they attempt to access a computer remotely. Setting of 1, which is what we're doing, disables user account control remote restrictions for local accounts. So this allows admins to connect remotely via tools like remote desktop or remote PowerShell to use full administrator tokens. So basically, it lets the scan engine like log into the machine and do what it needs to do and like look at what it needs to see, essentially. So we just copy this command. And you don't always have to do this. Like sometimes it's required. So I'm just going to do it, because I don't like error stuff and people getting stuck in the lab. So just like right click to paste it and say enter, and then it should be applied. So this is our virtual machine. So we're just going to restart the virtual machine for now. It's been prepared to scan. So we'll just go power and restart and make sure this is a virtual machine and not your actual computer, because it's easy to mess that up. And we'll let this thing restart. The next thing we're going to do is we're going to create a vulnerability scan configuration and check for vulnerabilities and STIG compliance. So we can actually start doing that right away. So to do that, we'll go to our email. If you're in the cyber range, you will have gotten this like credentials for Tenable. So to log into Tenable, like the vulnerability management platform, we can just copy this, new tab, and then copy our username. And let me log out because that's my admin. So I'll copy my username, copy my Tenable password. So we got logged into Tenable. And this is what the Tenable dashboard looks like, vulnerability management dashboard. So we're going to create a scan configuration that we're going to use to scan our virtual machine multiple times. So on the left, just click scans here. And then I have a bunch of scans that I'm just going to like delete these. So if you're logging in for the first time, it'll look like this. So we're going to create a new scan. And it's going to be an advanced network scan. So as a recap, we created our virtual machine, we configured it, and it's like ready to be like scanned. We opened up the firewall, and then we allowed the remote access to we allowed remote admin access to it. So now we're logged into the Tenable console and we're creating our scanner, or we're creating our scan configuration. When it's done, we're going to use it to scan our virtual machine. So back inside Tenable, we're just going to name it. I'll just name it like Josh Windows. I don't know. Josh YouTube VM demo something. And then we can leave all of this stuff. And for the scanner type, we're going to use the internal scanner, because remember there is, this is the internal scanner and this is the cloud scanner. We're going to use this one because it's just more efficient. So we're going to use the internal scanner, and then for the actual scanner, be sure to select the local scan engine if you are part of the cyber range. And for the targets, this is where we put our virtual machine's private IP address. And you might be like, what is that? And like, I don't know either, because I don't remember looking at it. Go back to the Azure portal and we go to virtual machines. This is the virtual machine we made. Don't click the cyber range ones, but click yours. You can see, because the resource group is a crazy name. Click the virtual machine. And then you will see oh my God. You should see under overview, there should be like private IP address here. This is the private IP address that we need to put in Tenable. So copy this. Yours is for sure going to be something different, but whatever it is, just copy it and then go back to Tenable, and then we'll paste this under targets. And this looks good so far. And then we can go to discovery. And then let's click use fast network discovery. And this probably doesn't matter much. We can probably leave these off. You can always like use ChatGPT or the Tenable manual. I'll put a link for that in the description to figure out like what this stuff is exactly. But we can leave this stuff off. Sometimes I just like turn it on like just to be sure, but I don't think it's necessary. Yeah, we can leave all of this. Looks good. And then for assessment, click on assessment. We'll just check it. We should be able to leave all of this stuff as well as default. I think so. I'll just look at advanced. I think it's good. And then for credentials, we're going to add a credentials. This allows the scanner to reach into the virtual machine. And like, if we add credentials, it allows like the scanner to like reach into the virtual machine, like log into it locally as an admin and really do like a in-depth look at everything. So we're going to add credentials. And our computer is a Windows computer. So if we go to host and go to Windows, and then the username, remember, we used lab user and then cyberlab123. So make sure this is accurate. Lab user, cyberlab123. And then check start remote registry, enable administrative shares, and to start the server service as well. Make sure all the stuff is checked and say save. And then we're going to go to compliance. And then add compliance audits. And this is something I had to add after the fact. So, because remember, we're going to do both. We're going to scan for vulnerabilities, but we're also going to do a scan for DISA STIGs. So to see like which STIGs or security technical implementation guidelines or security things on that checklist are already configured on the computer. So if we type, I think it's Windows STIG. Yeah, this should come out. This is not what I wanted. Oh, maybe STIG Windows. Windows 10. Expand this. Oh, here it is. So DISA Windows 10 STIG. So if you search for this, it should come out. You can just like ignore this. This is like, if there's certain settings that your organization needs to be in place, you can kind of define them here, but we'll just leave this as is and say save. And then under compliance audits, you should see this like DISA Windows 10 STIG thing here. If I recall, I had to load this in manually from somewhere. But if you're a part of the cyber range, that's like already loaded into our Tenable instance, so you don't have to worry about it. And then we can look at plugins really quick. And basically the scan is going to check for all of this stuff. It's not necessary to check for everything here, but I'm just going to leave it alone, basically. So we can save this, save the scan. We'll let this go. And then our scan is here. And the next thing we can do, we're just going to basically launch the scan and let it run to completion. And then we'll take a look at the results. We're going to make some vulnerabilities afterwards. Scan it again to observe the vulnerabilities that were made. We're going to fix them, scan it again, observe the results, and then we'll kind of wrap the lab up. So this is the first scan. It's just a baseline scan just to see what like kind of a quote unquote stock Windows 10 out of the box looks like in terms of vulnerabilities and STIG compliance. So to scan it, make sure your virtual machine is on. So I'll just like connect to it again. If you lost your virtual machine tab, you can go back to Azure, like portal.azure.com, go to virtual machines, which is here. This is your VM. and then make sure under virtual machines that it's running. Yeah, and here's our VM. If you want to connect to it again, connect and then bash in. But it's on, everything's on, and it's good. So I'm just going to go ahead and run the scan. So I'll say launch. And this should take probably anywhere from like 30 to 60 minutes to run, depending on how many other students are using it. But I'll just keep checking this, and we'll come back in like 30 minutes or so to check the progress. So we will see you then. And if your scan ends like immediately after like 1 minute or something, it's because like maybe the firewall is on or some other problem happened that you have to figure out. If you're in the cyber range and that happened, just post in the cyber community. But we'll be back in about 30 to 40 minutes. If you are experiencing issues like the scan finishes in like a minute or like 0 minutes, it means something bad happened. So you might have to post in the community to like figure it out, or just try to figure it out yourself. Like maybe your virtual machine is off, maybe your password is incorrect that you put inside of the scan. Maybe the Windows firewall is still on. It could be like a bunch of stuff. So, but yeah, we'll be back in 30 to 40 minutes or so and kind of see if it wrapped up. Cool. So we're back and the scan finished. If you hovered over the top of it, looks like it took about 26 minutes for mine to complete. And yours might have taken longer. Like, I don't know. It also might have logged you out of the portal as well. So when yours finished, as long as it didn't take like a minute, if it took like a minute and just like finished immediately and there's like no vulnerabilities down here when you look, it means something bad happened. So you got to figure it out, or go to the community or ask, in the cyber community. But go ahead and click on see all details, assuming everything worked out okay. And then we can organize these by severity, and then yours will probably look somewhat different than this, because the vulnerability scan is always different, and the state of the virtual machine is always like changing. Like you might be doing this like a month later when a lot of these have been patched by Microsoft. But you can see a bunch of vulnerabilities here, like TLS 1.0. You'll probably see this on yours if the VM is like brand new. You'll probably see like TLS 1.1 deprecated protocol. But these are just like, low. Oops, I didn't mean to click on that. Basically low, medium, and then high vulnerabilities. And a lot of these highs and criticals will go away, assuming like we go to our virtual machine and just run Windows Update a bunch of times. I'm not going to do it, but so for example, if you open Windows Update, and I say like check for updates, well, I just said I wouldn't do it, but I'm doing it. There'll probably be something here to like download and install, more than likely. I'll just like let it go for a second while I explain. See, there's like a whole bunch of updates downloading now. So, assuming you run these, you restart the computer, restart the VM, let it download the updates again, like keep doing it, and then scan it again. A lot of these will go away in the subsequent scans. But so these are the vulnerabilities. This is like our baseline scan of stuff that was found in, right? And you can, if you want, you can like click into these, for example. I'll just click on one to look at it. It will tell you like what the actual vulnerability is, like why it's a vulnerability, and then it will tell you how to fix it. And then you can always like figure out exactly like how to do this. So one like really boneheaded, like easy thing to do is just highlight all of this. I'm not going to go through the whole steps of this. I'm just kind of yapping right now. But if you go to ChatGPT and be like, my Tenable scan said this about my Windows 10 VM, what should I do? What should I do? And then if you paste this, it doesn't even have to be pretty. You see, I just dumped everything here that I copied. It's smart enough, because you even paste this plugin ID. It's smart enough to figure out like how to do it, and it'll tell you about the vulnerability. It will tell you like how to fix it. See, it's like literally like telling you every step to do, and this looks accurate so far. So, in the cyber range, like in the actual course, we go through like all of that. We do a bunch of like vulnerability remediation, like scanning, vulnerability remediation. We remediate a lot of them here, and then we do it in like the final project as well. but it's just, you kind of get the idea. We also do remediation with PowerShell as well. So we're going to remediate a vulnerability, but not this one. I just kind of wanted to show you this. But back in our scan, if we go back to the scan details, and then you remember the second thing we did is we scanned for like STIGs, for like audit compliance for STIGs. So if we click on audits, we see this tab here for failed, warning, and then passed. So these are all the Windows 10 STIGs that failed the audit, that are like not in place, if that makes sense. These are the warnings, whatever that means. So you can kind of look through these here. You can sort them by status, like so. So for example, these are all the things these are already in place, like right out of the box. These are the things that are in place already. Like the built-in guest account must be disabled. So that means the built-in guest account is disabled on the virtual machine. So for example, if we go to our virtual machine and I click start and I go to comp management.msc, computer management. So on our virtual machine, if we go to local users and users, you'll see the guest account, it's disabled. It's hard to see, but there's like a little down arrow on it. And if you look here, it says account is disabled. And that makes sense because the STIG passed for the guest account must be disabled. So let's just like go ahead and enable the guest account, because we're going to create some vulnerabilities on it just to like, see what happens. So I'm going to uncheck this so the account is enabled again, and we'll say apply and then okay. And we'll go back to Tenable and we'll just kind of like look around a bit. The built-in admin account must be renamed. It is. So these are all the past ones. So I'm going to sort this by failed status, and then I'll try to find a good one here that we can try to remediate, like something that's easy. So here's one. I don't want to do this one because this is actually in the cyber range, in the actual course, which you'll do. So let me see, like, what is there? Okay, I'll do this one if I can. The security event log size must be configured to be this large. I think this is like is this a gigabyte? I can't tell. I think this is 1 gigabyte. So if we click this, we can inspect it. This is like the STIG ID, the security technical implementation guideline ID, and it's telling you this is one way to do it. But if you copy this, we're not going to remediate this yet. I'll remediate it later, but I'll just show you something. So if you copy it and then you search Google, and then I think it's Stig Viewer, or Stigaview or something. You can see like this is the actual one here, and it will tell you like how to remediate it by making a configuration to the registry. So we'll do this later. So let me see. Uninstall Firefox. Fix Stig ID. This, and then fix Stig ID. And then the other Stig ID was we actually disabled, or we enabled the guest account. So let me figure out which Stig ID that was. I don't remember. If I sort this guest account, it must be disabled. It was this one. So I'll make a copy of this. It's for our checklist. Okay, so we're here. We're checking out the results. We created a vulnerability. Okay, so we're going to we enabled the guest account just to like break the STIG. So this breaks STIG ID. So we're also going to create another vulnerability on this virtual machine by installing a really old version of Firefox. If you want to see like all versions of Firefox, that you can use this link, but this is in particular, this is the Firefox I'm going to install. So I'm just going to copy this link. Then I'll go back to our virtual machine, and then we'll go to Edge, open up the internet. Make sure this is inside your virtual machine, not on your actual computer. You don't want to install some old version of Firefox on your actual computer. So just get through this. Okay, my connection dropped, so I'm going to reconnect. This is triggering me so bad. And then I will paste that Firefox link if I can manage to do that. Okay, so let me just copy that again. Copy. And paste. And then enter. And then this will download the old version of Firefox. If you think this link is sus, just use the other link and just download some random old version that you find from the Firefox's corporate site. But I trust my own Google Drive, so I'm just going to download it. So we can say download anyways. Hopefully this works for you. Looks like it downloaded, so we're just going to open this up. That took way too long. I'm not sure what this computer is thinking about. What can you possibly be thinking about this whole time? Weather alert. Where's this VM at? Struggling to do the most basic of tasks. Okay, so go ahead and install. I regret clicking on that really bad. So go ahead and install this old version of Firefox. Just next, finished, install. Okay, and let it go. Just say launch Firefox. It's probably not necessary, but I'm going to do it. So this is the old version of Firefox. So it's going to close this. Cool. And then back to our lab checklist. So far, we observed the results of the scan. We installed our old version of Firefox. We enabled the guest account just to intentionally break the STIG. So next, we're going to perform a scan to discover any new vulnerabilities that appeared. New vulnerabilities and broken STIG. So we'll go back to our virtual machine. We can close all this stuff that's open. I was going to say to restart it, but it's probably not necessary, but I will... yeah, let me just restart it. I'll say restart. And then when it comes back up, we're going to scan it again from Tenable. So I'll just go to Tenable again, and I'll go to scans. This is our scan here. Then I'll wait for this virtual machine to come back up, and then when I can successfully connect to it again, I will launch the Tenable scan. Then we'll go on a break for 20 to 30 minutes again, come back and observe the vulnerabilities. So let me see if I can connect to this again. It'll probably take 30 seconds or something to come back up. So the VM is back up. Go back to Tenable, and all we have to do, this is our scan. It completed already, so click the actions thing and just say launch scan again, and it will relaunch the same scan. And then this scan template will kind of have a history associated with it. So I'll just kind of show you what that looks like if I can. And we can say CL details, and then when this finishes, oh, there's history already here. And then there's the previous scan that we did. And then this current one, this is the one that's pending right now. But it's going to take, 20 to 30 minutes to complete. So I'll just go back to scans, and I'll just stop recording, and we'll come back in a half an hour and see what comes out. So we'll see you soon. Okay, we're back, and the second vulnerability scan finished. So we're just going to check the results, what happened after installing Firefox and then breaking one of the STIGs. So let's check it out. So we can just click the actual scan here, and then you can see all details. And then before we start looking at the scan results and the audits and stuff, click on the history tab. I just wanted to like get you in the habit of these. And then you can see that we have completed 2 scans. The first one took 28 minutes. The second one took 25 minutes. And then you can see which scan we're actually looking at based on like this current tab here. So if we want to look at the previous one, we just click on this, but this is correct because you can see it has the later time, right? So we're going to look at vulnerabilities by plugin first, and then we'll sort it by severity. Make sure critical is at the top, and then you see like tons of Mozilla Firefox vulnerabilities just from installing that one like old piece of software. There's like whole bunch of them. And then if you click this at the top, like remediations, you can kind of see these are like the different actions you can do, and then the number of resulting vulnerabilities that get cleared essentially. So if we were to upgrade Mozilla Firefox to this version, which I assume is like the latest version, it would fix like 322 vulnerabilities. And then of course, just straight up removing Firefox will fix the vulnerabilities as well. And then these are kind of the rest of the vulnerabilities that will probably, like some of them will probably get resolved by updating Windows. But going back to vulnerabilities by plugin, you can just see like a whole bunch of Firefox vulnerabilities here. And then if we click on audits, you'll remember the first one had to do with a guest account. So the first time we scanned this computer, the guest account was disabled. So if we search for guest, you'll see like the built-in guest account must be disabled. Now this is failing because we actually enabled the guest account. So this flipped from being pass to fail because we enabled it. And then this one is like still failing, like the guest account must be renamed. So maybe this would be like another good one to like remediate when we go to like fix it. So I'm just gonna like copy this STIG ID and then go into our checklist. And I'll say like, fix STIG ID. This. We'll go back to vulnerability management. Accidentally clicked on that STIG. So what was the other one? I can't remember. Oh, the security event. Security event. We can also just search the STIG ID. So like this is the other one I took note of. The security event log must be configured to be at least this big. I think this is like 1 gigabyte, I think. So just as a recap of what's going on, we created a virtual machine. We configured the scan, the scan configuration inside the Tenable console. And then we configured it to use the internal scanner. And then we used the internal scanner to scan our virtual machine. We scanned it once as a baseline scan, like a fresh VM straight out of the box. We installed an old version of Firefox on it and then enabled the guest account. And we scanned it again. And we saw that the Firefox created a whole bunch of vulnerabilities. And the guest account being enabled like failed a STIG. So the next thing we're going to do, now that we scanned it, seeing all the vulnerabilities, we're going to remediate the Firefox vulnerability by just straight up uninstalling Firefox. And then we're going to remediate the other STIGs by, let me see. I forget which one is which, but one of them is like we're gonna disable the guest account. Another one is we're gonna like rename the guest account to something else, and then the final STIG is to increase the size of the Windows Event Viewer security log. So we'll just get right into those. The first thing we're going to do, we're just going to uninstall Firefox on the virtual machine. So go ahead and get logged back into your VM. If you like closed out the VM, you don't remember how to log into it again. If you go to Azure, like portal.azure.com, and then just log in with your crazy email. And then I'm going to get my password. And then I have to log in with Authenticator. If you're in the cyber range, you have like, I believe 2 weeks to register for MFA, but I recommend just doing it right away because it's going to reduce any login issues you have. Like anyway, just do it right away. I don't want to take too long to explain those. Like Azure it's possible that Azure thinks like something's wrong with your account. Like if you log in from different locations, but if you have MFA enabled, it won't like lock you out. So just enable MFA right away. But anyway, to get back to your virtual machine, you just search for virtual machines, and then pick your VM, not the CyberRange VMs, but yours. And then log in, go to connect, and then bashin. This is just how to reconnect to it. And then just put your username and password. I use lab user. And then I use this password. And just say connect. And it will open a new window. You might be blocked by a pop-up blocker, so just allow the pop-up. And then recap, we're going to uninstall Firefox, and then we're going to work on fixing these STIGs, and then we're going to do one final scan. So back in our virtual machine, Firefox is here. So I'll show you a fancy trick. If you click the start menu and you type appwiz.cpl, appwiz.cpl, it will open up the uninstall programs folder or window, I guess. And then you can actually uninstall Firefox straight away from here. In real life, you know, if you're doing vulnerability management, you might go through, you wouldn't just uninstall it. You would see if it's part of your normal loadout for your company. And if it is, you would make sure that you're allowed to update it. Like usually companies will have like a third-party patching process in place. But if they don't, it's your chance to spin one up. And you can look up NIST 800-40, I believe, for that. Enterprise Patch Management. I go over this in depth in the CyberRange, like, you know, doing patch management. But anyway, so Firefox is uninstalled. So what's the next thing we're going to do? We're going to start fixing these STIGs so they pass. And I don't remember which one is which, but we can either look in Tenable. So for example, if we search the STIG ID here, this is our scan, and we can see the security event log must be this big. And if we go to like STIG viewer, for example, STIG viewer, and then search it. I think there's another site called Stigaview or something, Stigaview. And I'll search that STIG. Oh, Stigaview and then the STIG. So we'll click on it. And it's telling us how to fix it using the Windows registry. So we can try to do that. We can try to do this with the Windows registry. So just copy this registry key here, this path, and then go to your virtual machine and then click start and then type registry. And I'll kind of explain what this is. Make sure you're doing this in your virtual machine and not your local computer. Make sure it's in your VM. So click start registry. And then open up the registry, and then basically like a crash course, like 1 minute or less crash course on what the registry is. It's basically just a whole bunch of settings inside of Windows that you can configure that there's not necessarily a graphical user interface component for. Like there's a lot of settings in Windows that you can configure, and if there's like a GUI for every single setting, Windows is going to be like absolutely gigantic. So there's the registry which exists where you can change stuff in here. And you can like change settings inside of Windows. So we're just going to paste that thing we copied in from Stigaview. Like I copied this registry path. So in our virtual machine, if we paste this here and paste. Oh, we couldn't go to them. Okay, that didn't work. So let's go to local machine and then software policies, Microsoft. So we'll go back to the registry. HKey local machine. Oh, that's why. So after local machine, I think we can paste that software policies Microsoft and say enter. And yeah, we could. Oh, it didn't actually go to it. Okay, so we'll go to local machine, then we'll go to software policies Microsoft Windows, software policies Microsoft Windows, event log security. So we go Windows, software policies Microsoft Windows, and I don't see an event log key in here, so we got to create it. So Microsoft event log, I believe. event log security. So we'll create the security key inside of the event log key. Event log security, Windows event log, a new key, security. And then inside of security, we'll create a D word called max size, and we'll give it the decimal value of this. So we'll create a keyword inside of security, or a D word, sorry, called max size. And then it needs to be this big in hexadecimal or this big in decimal. So I'll just I'll pick this because my human brain is easier dealing with decimal. Oh my God, bro. $10.24 and 3 zeros. Yeah, it looks good. We'll say okay. And then this should fix the first stig. Another way possibly to do this, I'm not sure if this is actually going to work, so don't do it. But, oops. If we click like the start menu inside of the virtual machine, and then we go to event viewer and open this, you can actually like see the size of the security log inside of here. So if we go to like Windows logs and then security and then right click it and then properties, I don't think this is an adequate way to set it in terms of like what the scanner will recognize as fixing it, but I'll just show you it anyways. So you can see the maximum log size here. It's like whatever this is, like 20 megabytes or something, or 20,000 kilobytes. Technically, the thing we did in the registry should like adjust this, I think, after we restart the computer, but I'm not sure. I've experimented with this a lot, but the way to like fix it so it actually works is to like set it inside the registry as described here. Cool. So technically, this stig is fixed. So let's work on fixing the next one. So we'll copy this and see what it is. I think we can just like, to be honest, I'll just Google like stigaview, and then paste it, and then go to this. And then what is this one? The built-in guest account must be disabled. Oh, right. So one of them is the guest account must be disabled, and the other one is the guest account must be renamed, I think is this one. So I'll do like stigaview, and then stigaview. Click on this. The guest account must be renamed. So we can do both of these at the same time. We'll disable it and then we'll rename the guest account. So back in our virtual machine, if we click start and go to comp management.msc, then open up computer manager, and we go to local users and users, and then guest, and I think we can rename it. I'll just, I don't know. I'll just rename it guest X and see if this works. And then I will also disable the account. So go to properties and then go account is disabled and say okay. And then that should have, we uninstalled Firefox. We increased the size of the security log. This one's a bit questionable because we did it in the registry. We just have to see if it works. And then we enabled and renamed the guest account. So increase size of security event log, disable guest account, I think rename guest account, just FYI. So now all we got to do, we'll just restart the computer, start the VM, and then we'll do another scan. I should put restart VM here too. Restart VM. Cool. So I'm not sure if that's required, but it's kind of good to do because Windows is like weird like that. So I'm just going to go ahead and do it. And then when the virtual machine comes back up, we're going to initiate another scan on it and then observe the results. And then we'll kind of organize things and look at it at a high level And then we'll go over, what you can put on your resume if you did this like standalone version, and what you can put on your resume if you happen to be in the cyber range, or if you're interested in doing the cyber internship. So we will let our virtual machine see if it comes back up. It's probably going to take like 30 seconds or something. Okay, I'm going to close this, and then I'll just like reconnect. So Cyber Lab 1, 2, 3. So the VM is probably still coming back up. It's no problem. So let's try to connect again. Cyber Lab 1, 2, 3. So Windows is back up. So let's go ahead and start our scan. So we'll go back to Tenable, and we'll go back to scans, and then this is our third and final scan for the lab. So we'll click on this and then just say launch, and then we'll come back and like another 20 minutes or so, observe everything, and then kind of wrap the lab up, and then cover the resume portion of things. So we'll see you in a few minutes. Cool. So our final scan finished. Just as a recap, we just, use the console again. We scanned with our local scan engine. We scanned our virtual machine a third time. So now we're going to look at the results. Remember, we removed Firefox and we cleaned up. We should have been able to remediate 3 different STIGs. Maybe one of them failed. I don't know actually, but we can see already there's like way less vulnerabilities. I don't know if you've been like keeping track before, but let's click see all details, and then before we like really dive in, we're just going to review the history. This is the first scan, second one, and then the third one, for whatever reason, took a few minutes longer. You can see the time discrepancies. So let's check vulnerabilities by plugin first, and you'll notice there is no longer any Firefox vulnerabilities because we completely removed that, which is cool. And then if we look under audits, there's still like a lot of failed audits, but let's like look at the STIGs one at a time. So here's the first one. Increase, this should be size, increase the size of the security event log. So we'll copy this, go back to Tenable, and then we'll paste this. And hopefully this passed, and it passed now. This used to be failing. And you can like double check, what this Tenable is looking for when it does the scan. So if we click on this past STIG, or past PASSED, we can click actions, and we can say view output, and we can see like what this is like a bit confusing, but this is the registry key, like the value of the registry key that it found, and it needs to find a value from this amount to this amount, and it found this, which is on the the lower bound, but it's still included. And if you remember, this is just the registry key that controls the size of the security event log, and we found that inside of STIG view somewhere. It's not one of these ones, but it's somewhere in here. I think it's this. Remember, we like went to the registry, we went to this place in there at registry, we created a max size key, and then we assigned it this value, and then of this size, 1024.000 or greater, and the Tenable, it found 1024.000 or greater. It found 1024 here. So it passed. And then the next one's the scan details. So let's look at the rest, the two more STIGs that we've tried to fix. This is disable the guest account. So let's copy this STIG ID, go back to Tenable, and then we'll paste it in here. And then we did disable the guest account, so it should be green, and it is. So if we click on this, and it's disabled, we can view output and see if there's anything like that makes sense in here. It's looking somewhere. I don't know exactly where this thing is like looking for the term disabled. It might be doing, it might be using like, well, I don't even want to guess. It might be using something with WMI, or it might be looking in the registry somewhere. I don't actually know where it's looking, but we just disabled it with inside Computer Manager. So It's disabled. And then the last thing is this STIG, which is rename the guest account. And you'll remember we renamed the guest account to like guest X. So if we open up computer management, go to local users, and in users, we can see the guest account is now named guest X. So this STIG should be passing. So if we go to Tenable scans and we search this STIG, oh, no data was found. Why is that? Oh, I need to go back to scan details. My bad. I'm getting tired. So back to the STIGs, we'll search it. And we found it here. Guest account must be renamed. It is. So let's check out what the output it was looking for. See if it says anything that makes sense here. So the policy value is guest, but it actually found guest X. So that's good. It's no longer named guest. So at least those STIGs passed. And go back to scan details. You can still see there's like a lot of stuff that needs to be remediated on this virtual machine. Like if we clear this, like in terms of, the failed STIGs, at least there's like a lot. You can spend time like doing this. And spoiler alert, that's part of what the internship is figuring out programmatic remediations for STIGs using PowerShell. We dive into that a lot in like the CyberRange courses, but I'm not going to like do that because this video is going to get like way too long. And back to vulnerabilities by plugin, there's still like a decent amount of vulnerabilities here, but we cleaned up the Firefox ones. In the actual CyberRange, we clean up some of these other ones as well. But for now, we're just going to plot a visualization of the vulnerability trends over time for this virtual machine. So to do that, I'll just kind of show you, I guess, what that looks like. So we're going to open this remediation data sheet, and then you'll make a copy of it for yourself. So just go to File and then make a copy, like so. And I'll put this in like a new window. So I'm going to do like some side-by-side thing here. And you can close this one. That's like kind of the previous one that we made a copy with. So we'll go to Tenable, and then let's go to History. And then let's click on the first scan. And we're going to use this for our portfolio. And then, so this is the first scan. So we'll go to vulnerabilities by plugin. And then we'll just look here, like 1 critical, 15 high, 31 mediums. So this is scan 1. So there's 1 critical, 15 highs, 31 mediums, and then 3 lows on the first scan. So we'll go back to history, and then we'll pick the second scan. And then, we can see it here already. So 25 criticals, 11 highs. So now the second scan, there's 25 criticals because we installed Firefox, and then there's 11 highs, which is like a lot more. And then there's only 16 mediums and then 3 lows. It's interesting. There's less mediums. Probably, I'm guessing, because Windows updates must have ran or something at some point, which may have decreased some of the vulnerabilities. So let me like check this again. This is the first scan. Yeah. So let me see. 1 critical, 15 highs, 31 mediums, 3 lows. That's correct. And the second scan. "25 criticals, 11 highs, 16 mediums, and then 3 lows." And then the third scan, which is the final one, there was 3 criticals, 6 highs. So only 3 criticals, 6 highs, 13 mediums, which is less, and then only 2 lows. And then actually this chart should like technically end after the third scan. If you want to, you could look at vulnerabilities by plugin and then try to figure out how to remediate the rest of these. I cover a few of these in the CyberRange, like how to remediate them, but like a lot of these, So we could actually do one more scan with this. Maybe after we clean up some Windows updates, like run Windows updates on the virtual machine as much as we can, to where there's like no more updates that can be done, and then maybe restart it, and we'll try to do one more scan and then see if we can further reduce the vulnerabilities anymore. So just to kind of see, a lot of these for sure have to be like manually fixed, like this like TLS one we do in the cyber range. But I'm sure we can like clean these up if we run Windows updates. So let's just get reconnected to our virtual machine if we can. So connect, bash in. So you'll notice like some stuff on the desktop here. It's just because there's like an attack simulator on the back end in the cyber range, and this computer got ransomwared. It's like your files have been encrypted, and then the corporate files on the desktop got encrypted. It's just like an exercise. But anyways, we'll just finish updating Windows. So update. Just update this as much as we can. So to do this, you'll just have to say check for updates, install updates, and then maybe restart. Check for updates, install updates, maybe restart, and keep doing that until there's like no more updates that can be done. It's possible this VM is like already updated as much as it can be, because this is the next day and it was on for a bit before I went to sleep. So it's possible that it updated itself, but we'll figure it out. Let me just check the IP address to make sure it's still the same, the private IP address. Wow, that is lightning speed. 10.0.0.42. So if I go to Tenable and then I go to our scan, which is here, I just want to make sure that the private IP address is still the same. 10.0.0.42 it is. Okay. So back to the virtual machine. So it's installing updates. So I'm gonna like pause the video and then let this thing go, and then I'll restart it once it comes back. So we will be right back. So it says I'm up to date. I didn't have to restart or anything. It just said I was up to date. So I'm gonna check one more time, and if it still says I'm up to date, I'm just gonna restart the virtual machine and then redo the scan, and then we'll take a shower and check out the vulnerabilities afterwards to see if they've decreased at all. Okay, so there's none. So at least Windows is up to date. So we'll go ahead and restart this. And when it comes back up, we will do one final scan. And I will say, like, while this is happening, there's quite a bit to vulnerability management in the real world. There's like a lot of nuance to scanning, because usually the person scanning it is not the same person assessing the vulnerabilities, like to prioritize them. And then that person's not usually the same as the person who's actually fixing them. And then the person who's fixing them is not the same as the person who's like verifying that they were fixed by like redoing the scan. Usually, like, for example, if the organization is big enough, like every step of the vulnerability management lifecycle is usually done by like a different person or a different department. But if for separation of duties and all of that stuff. But if the organization is too small and there's like only one person doing security, it's better to have one person doing all this stuff than just no one doing any of it, if that makes sense. So I just want to give you that context that it's a bit complicated in real life. And also in the actual cyber range, while the computer's restarting, I'll kind of explain it. There's like two sections. There's like a vulnerability management theory section. You can kind of pause this and look at it if you want. There's quite a bit covered in the whole theory that I glossed over like really fast in this video, because it's going to get like too long if I try to like teach everything. It doesn't make sense to like teach everything in one go anyway, because it's just a lot. And then when it comes to actually the hands-on part of vulnerability management, there's also like quite a bit that we do. There's like quite a bit of explaining that needs to happen. This is the actual like full course in the cyber range, and we do like a whole thing where we implement a whole vulnerability management program from the very beginning induction to like drafting the vulnerability management policy and getting the stakeholder buy-in and like having a bunch of mock meetings and like all these rounds of remediation. There's like quite a bit in here. I just like went over it really fast in this video just for the sake of doing like an easy to follow YouTube lab, if that makes sense. But yeah, so if our VM is back up, I will go ahead and initiate the final scan. And also in the cyber range, we also do vulnerability management against Linux as well, because you will do that in real life. So once I get logged in, it's probably okay to scan the computer now, but I'm just gonna let it log in. So we'll do our final scan. I'll just say launch, and then I'll go take a shower or something. We'll be back in 20 minutes or so, and we will wrap things up. Okay, the last scan finished, so let's take a look at it. And we can see there's a lot less vulnerabilities already, but let's see all details. And it looks like there are no more criticals, only 6 highs, 11 mediums, and 2 lows. So I believe we can add these to our list here. So what did I say? So the last scan, there are now 0 criticals, because Windows updates remediated like a lot of stuff. So there's still 6 highs, there's only 11 mediums now, and then 2 lows. And then we can kind of see a nice downward trend. So we're going to stop at scan 4. So I'll like double click this and edit the range. And let me see. So we only recorded up to, what is this? Column E. So instead of F6, we'll say E6. E6, and then we have our nice graph. So we can see in the beginning, yeah, I'm not sure why initially there was like only 1 critical discovered. Probably something to do with Windows updates, and like maybe Windows updates partially ran and it introduced new vulnerabilities or something, because normally you should probably see something that like looks more like looks more like this, where there's like kind of more criticals. But anyway, for us there was 1. So we see like the initial scan, and then we see like an uptrend when we introduced Firefox, and then we remediated Firefox as well as like ran Windows updates, and then we can kind of see like, oh, this is the one where we remediated Firefox, and then we ran Windows updates, and then it decreased even further. And you can decrease this like even more and more, right? If we remediate some of the other vulnerabilities that were found, like some of these like highs and mediums, which we'll do some of these like in the cyber range as well. But yeah, this concludes the actual scan portion of it. Next, we're going to go through, I'll show you what your portfolio is going to look like with this project in it. And then I'll kind of point you to where like a video that you can watch to actually build a portfolio. And then we'll get into what you can put on your resume in terms of projects after completing this. And then I'll kind of talk about what your resume will look like if you do the cyber range, like if you join the cyber range and go through the internship program, because there's like vulnerability stuff that you can do in the internship program where you can put actual experience on your resume, like under the experience section for my company, and then have potential employers reach out to me for employment verification. So yeah, that's up next. Okay, so now I'm going to show you what the project is going to look like in GitHub, and then I'll kind of show you how to create your own GitHub portfolio and then copy this project into it to then put on your resume. So I'll put a link. There'll be like a document in the description of this video that you can click on, and there's like steps to everything in there. It will look something like this, the document. And I'll put a link to this in there too. This is the actual GitHub project of the thing that we just did, like the whole vulnerability remediation thing. I'm not going to explain the whole thing. I'll just go over it at a high level, then I'll show you how to create a copy of it on your own. So basically, it's just like a summary of what we did, the lab architecture and overview, then a picture of the lab, right, that we talked about a few times, some key concepts, like what we're going to do in the lab and some of the tools used, and then kind of a step-by-step of what we did. Like we configured a virtual machine in Azure, we prepared it for scanning. And you can put more stuff in here. Like you can talk about how we pasted the PowerShell to like change the registry key, and how we disabled the Windows firewall, and talk about why we did that, right? Like put more screenshots in here, but this is just kind of a scaffolding, I guess, that you can use for like a basis for your project. And we talked about the scan configuration. I just show like a single screenshot of it. And this is good, right? Because when you have projects in your GitHub, you want it to be like when an employer or somebody opens it, you want to have like something visual in there like right away. I might even like reduce this text so they see the picture sooner rather than later, and it hooks them. Because when people open a GitHub project and it's just a bunch of like code or like text and it's incoherent, they just won't look at it, or it won't like mean anything to them. But yeah, this is the scan, and we talked a bit about what we did. We looked at some of the STIGs that we're going to deal with, like the increase the size of its security event log. Like these two failed initially. This one passed because the guest account was disabled already, and I kind of show some screenshots of all those things, like the STIGs. And then I talked about how we intentionally failed this STIG by re-enabling the guest account. And then I talked about how we've remediated the vulnerabilities, like removed Firefox, updated the registry to increase the log size. We disabled the guest account, then we renamed it, fully updated Windows. And these are kind of like the results from our scans, like the initial scan. And then the second scan, there was more vulnerabilities because we installed an out-of-date Firefox. We uninstalled it, scanned it again, there was less. Then we fully updated Windows, and then there was even less vulnerabilities in it in the end. And this kind of shows like the trend of what we did during the project. Kind of explained that here, and then why this lab. So this is basically what the lab will look like. Right? So to get this, to get your own GitHub portfolio, I'm not going to explain the whole thing in this video because it's too long, but I'll put a link where to find that in this document that you're probably looking at. So from within the free cyber community, there's a lesson like GitHub account and main page creation. So you'll just like click on that. It looks like this, and it's just like another video that shows you how to go through and like actually create your GitHub portfolio and then have like kind of the main page ready to use. And after you go through that, it will look something like this. This is like kind of the main page. And then so to get this project into your GitHub portfolio, like once you're at this screen where you kind of have your own portfolio and it's just like a blank page, maybe there's some like fake projects on here because you copied the tutorial exactly, you'll go to like repositories, and then you can just create a new repository. And then I'm just going to name it, you can name yours like Windows 10 vulnerability management or something like this. So Win 10 vulnerability management. I'll just name mine YouTube so it like doesn't get confusing. Make sure it's public, and then say add a README file here, and then say create repository like this. And then you'll have like kind of a blank thing like this, and then you're just going to edit. It, and then you have this like kind of empty thing here. If you say preview, you'll just see it's just a blank thing. So go back to edit, and then you'll go to this one. And then this is the project we're going to copy over. So this step that says copy vulnerability management, Tenable demo project markdown into a new repository. So to do that, you can just actually, I think you can just copy raw. I think you just copy this. Oh, so click on raw. And then this is like the text representation of that whole project. So if you like just copy all of this and then go to like your empty repository you just made and just paste it in here. And then if you say preview, you'll just see it like here already, like everything is here. And then I would just say commit changes, just so you can save it once. And then if you want to, so for example, if you want to add more screenshots to this, say, just for example, you want to put something like, I'm just going to put a random screenshot under here to show you how to do it. Like I'll put something under here. So for example, I can say edit. Then I'll like, find the place where I want to put something. And then you can just, for example, I'll just make a new terminal window to take a screenshot of. So, however you take a screenshot of the region on Windows, I'll just take a screenshot of this like window, for example, right? And I'll copy it with Command C because I'm using Mac. And you can just simply you can just paste images directly into GitHub like this. like so. And then it will upload. And then if I go back to preview, you'll see the thing I pasted in here. It's this. I'm not gonna like commit this, of course, because it doesn't mean anything, but you can just add a bunch of pictures to this, like as much as you want, or change it however you want. I recommend changing it to kind of like quote unquote make it your own, right? But once you're satisfied with it, just make sure to say like commit. So for example, I already did it, but you can say commit changes when you're ready. And then you kind of go to like the main page of this project you have here, right? And then you would just like copy this portion of the URL like so. And then you can go back to your main page, and then you can actually edit this main page. For example, you say edit, and then you can always just like paste it here, and then it will make like a new link. You can like link directly to it, right? So maybe under vulnerability management projects, I'll just like, put something in here, like simple YouTube vulnerability management demo with Tenable, something like this. Like so, just copy the notation that I'm doing. So, and then you can say commit changes and just say commit. And then it will be committed to like your kind of main profile. So if you go back to like your main profile here, there'll be this like simple YouTube vulnerability management demo with Tenable. And if you click it, then it will load this project, and then people can kind of see this. Of course, you can always like link directly to this, but the URL is like kind of long. But so I would recommend just on your resume, just link to like github.com/ and then whatever you ended up making your username, so people can just like see it. So for example, I'll put a copy of this. This is the resume template we use in the CyberRange. So I'll put a copy of this like in that instruction sheet. But anyway, this is like the resume, and then you can just put it in here, something that looks like this, github.com/ your name. And then when people go to it, they can see your profile straight away, and then they can see your projects. And then if they click on this one, they can see like a nice, beautiful project here. And these other projects, these are stuff that's part of the CyberRange. Actually, you can look at these if you want. I'm not going to talk about it in this video, but these are some of the projects that we end up making in the CyberRange if you were curious about those. But yeah, that's how to create your GitHub portfolio and insert the project in it and put that on your resume. Next, I'm going to talk about what your resume might look like with this project on it. In this section, I'll show you what your resume would look like with your portfolio and this particular project on it. So the next step, I would recommend like watching the resume construction video in the free cyber community. It's free, which it's right here. I talk about like the importance of organizing your resume in a certain way, and a bunch of other stuff that's like really important, and like why it's really important for your resume to be as good as it possibly can be. It's free, so just watch it. I won't put it in this video because it's just going to get too long. But after you watch that, make a copy of the resume template that's inside of this video. So for example, if you click on this, or I put the same link in this other document that you're looking at, but if you click resume template, this is the resume template I recommend that you use. Just for simplicity, I won't talk about it too much, but to make a copy of it, just make a copy. I would name it something relevant, and then I would make sure to get your GitHub profile link, like the main one, and then put it here. If it's not already here, I don't think you need to put like HTTPS. And then, by the way, this like whole chunk, this experience chunk here, this is like for the CyberRange internship. Like if you go through the internship and do the stuff in there, you'll end up with something like this to kind of put on your resume for experience. And it's actual like internship experience, and it works. People calling me to verify employment and internship participation all the time. So if you're wondering what that is, that's what this is. But under projects here, you can change this to like vulnerability management with Tenable, something like this. And then you would get the link to your vulnerability management project and click this. Just copy this. And then the source is here. So you can just paste this here. And then I would get rid of there's no need for that. And platforms and technologies used. We use Tenable. We didn't use SIM for this. This is for the cyber range. We did use Azure Virtual Machines. We used Azure Bastion. And I think that's probably all we used. Platforms. Yeah, I think this is pretty much all. Yeah, and then you could even depending on how much real estate you have on your resume, you could create a one-liner here that talks about what we did exactly. So for example, maybe you would make this underlined, and then maybe you could for example, copy this all this text or whatever, for instance, and then just go to ChatGPT and be turn this into a one-liner for my resume talking about the project, and just paste it. And ChatGPT, it should come up with something coherent. If it's too long, just say much shorter. Something like this. This is probably okay. You can spend more time scrutinizing it if you want. So built a cloud-based vulnerability management lab using Tenable and Azure for real-world security testing and STIG. I can say STIG implementation. This, damn, I wish this didn't wrap. I can get rid of this. Yeah, so this is STIG implementation. And this looks pretty decent to me already. It's decent. So now I'm just going to explain a bit about the cyber range and cyber community a bit, because I've been kind of talking about them a lot throughout this video. So I'll kind of tell you the difference between them and kind of talk about what's in them a bit. So basically the cyber community on the left is a free platform on School. It's like a community. Maybe there's about 1,300 members in it right now. It's free. And then the cyber range, which you're seeing on the right, is also a School community, but it's not free. It's paid monthly. Currently it's $97 a month. And there's some extra stuff in there, but I'll kind of explain them. Basically the content is the same between the community and the range, but the cyber community, modules 3, 4, and 5 are locked. Module 3 is vulnerability management with Tenable. It's kind of a full-blown thing of what we just kind of went through, but there's much more, and we go in depth for the different scan types and a whole bunch of different things. There's a lot of vulnerability management stuff inside of here. And then module 4 is threat hunting, security operations, and incident response. And basically we use Microsoft Defender for Endpoint as our EDR platform to do threat hunting. And then we use Sentinel to do some kind of general security operations and incident response. And there's a lot of KQL, Kusto query language querying that we use to query logs and stuff. And then module 5 is an internship program where you can get actual experience to go on your resume. And I will vouch for it. People will call me or email me to do employment verifications. And I'll give them a normal verification because it's actual work you're doing. And then you can use that as experience on your resume and your LinkedIn. And it actually works quite well. I do at least one verification per week, possibly more these days. But basically the cyber range, previously in my cybersecurity course, everyone would have to use their own Azure instance, their own cloud instance. But for the cyber range, it's basically one big shared environment. So when you join, you get access to my company's Azure subscription as well as my Tenable subscription. And you use Tenable, it's fully licensed enterprise vulnerability management platform to scan virtual machines and do other stuff inside of the Azure subscription. So basically you'll sign up and you'll provision your account and you'll get some kind of emails that looks like this. That has your username and password for this is your access to Tenable vulnerability management, and then you'll get another one for Azure, and then you can log in and kind of do this, for example, the stuff that we did today in this video. And then what you're looking at here, this is just this is my actual live subscription. These are a bunch of random students' virtual machines. There's about 3, actually I can tell you exactly. So cyber range, there's 323 users currently, but not everyone. There's not like 300 virtual machines, because not everyone is like, people tear down their virtual machines when they're done with it. But these are a bunch of VMs that the students are using. And then, for example, if you're familiar with Azure, like when you get your account provisioned, a resource group automatically gets created for you. So these are all the student resource groups, and you basically have like admin access over the virtual machine and stuff in your own resource group. This one's empty. This one's probably empty. But when you create a virtual machine inside of it, you can pretty much create like any operating system you want, and you have just full admin access over it. And then there's a bunch of other stuff. So for example, you can pretty much see like everything. Like, this is basically a live work environment. It is a work environment. Other people are logged into it and using it. So for example, if we go to like Active Directory, for instance, it's called Entra ID now, but this is where all the user accounts are stored. So if I go to manage and I go to users, I can see all the different CyberRange members, usernames and email addresses in here. But I made their username a SHA-256 hash of their actual school email address. So it kind of obfuscates it, and it takes care of privacy. Like I'm not like liable for a GDPR or whatever, because I'm not even like holding any of their actual, PII. So these are like all the different students. So when you log in, so for example, this is my username, for instance. And if I go to users, I can like search it, and it will come out in here, right? So this is me. And then you can literally see like it's like a work environment. It is a work environment. So you can see literally everything, like everyone logging into Azure and doing stuff creates logs, and you can do all kinds of things with those logs, like create Sentinel, like SIM alerts, and do all kinds of stuff. Create workbooks. So for example, this is like the last kind of thing. I'm just like showing you random stuff. I didn't really like plan this out, but these are just workbooks I created, which you'll do like when you go through the CyberRange. But for example, Enter ID success, Enter ID. Enter. So this should be Microsoft Azure. Like when somebody successfully logs into Azure, it should plot it on a map and show basically where all the different CyberRange members are, like all across the world. And sure enough, you can see it. And it will show like, it's probably tiny, but you can see like the username that I'm hovering on down below. And there's some in Japan. So you can see, you can see Josh Madakor, my actual account. You can see it. And then the other one, Artisa, that's one of my, it's one of my coworkers. I'm training her to do like to manage the CyberRange from like a automation Python, like engineering standpoint. And this is probably me. See Josh Madakor from Dubai. I was in Dubai like last week actually for a conference, and there's just like a bunch of other people. Like the actual CyberRange students, their email and stuff is obfuscated, so you can't see like, for privacy reasons. But yeah, that's a CyberRange. It's basically just a large work environment. And that lab we went through I made use of Tenable and like Microsoft Azure and the CyberRange in general as a student. So there's much more to it than what I showed in this video, but yeah, that's the CyberRange. Yeah, I hope you enjoyed it. I plan to make more kind of demos like this in the future. I'll probably do one for like general security operations. I'll do one for threat hunting. I'll probably do another one for vulnerability management, but instead of STIG, I'll do CIS or something. So let me know in the comments. I know people have been asking about Python a lot, and I have like a ton of stuff for Python, because the whole CyberRange backend is a whole bunch of Python, like those account automation, like the automated creating of the account and resetting passwords, and like all that stuff is like just a ton of Python. So let me know like what kind of demos you want to see. I'll definitely listen to you. And I do want to say, I do respond to like everybody's DMs in the cyber community and the CyberRange, especially because in CyberRange, like people are paying for it. So if you want to like talk to me, like don't abuse it, right? Or I'll just like I'll stop replying to people if you like really abuse it. But if you want to talk to me directly, just join the cyber community. It's the free one. I try to aggregate all my communications there. So I'll put links for like everything in the description, and let me know if you like this lab. Give me feedback and stuff, and let me know what you want to see in the next videos. And yeah, we'll see you later in the next video. Thanks for watching.